Hello, what we're going to be talking about in the next few videos is NumPy. So what is NumPy? NumPy is a library for the Python programming language, adding support for large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. It is a very important library for data science with Python, since almost all the libraries in the PyData ecosystem rely on NumPy as one of their main building blocks. NumPy is also incredibly fast. So what you need to do is you need to go in and install NumPy. So from the command line, you want to cd to the scripts folder of your Python install and type the following command, which is pip3.exe install and NumPy, and that will install NumPy into your Python, and you'll be able to go ahead and use NumPy. So the main thing that NumPy provides is the ability to work with very large arrays. So NumPy arrays essentially come in two flavors. There's either vectors or matrices. Vectors are strictly one-dimensional arrays and matrices are two-dimensional, but you should note a matrix can still have only one row or one column. So what we're going to do next is we're going to actually go into Python and start using Numpy. So let me just go ahead and open up a shell window, and the first thing I'm going to do is I'm just going to go in and type in a list into Python. So I'm just going to create a Python list, and we're going to set that equal to 1, 2, 3. Go ahead, hit enter, and then we will display the list. And basically what we have is we have a list of 3 numbers. So with NumPy, you can take any Python list and cast it into a NumPy array. So that's what we're going to do next. So the first thing you need to do is you need to go ahead and import NumPy. So I'll just go ahead and import NumPy as NP. And then after I import it, I can just go ahead and use the array method in NumPy to go ahead and convert my list into a NumPy array. So I'll just go ahead and set array ARR equal to NumPy, and then we'll call the array method, and we're going to go ahead and call it on my list. And then we'll go ahead and display it. And now what we have is we have a NumPy array that we can use all of the NumPy array methods and other tools that are available in NumPy to go ahead and work with that array. You can also go ahead and convert a list of lists in Python into what we call a matrix. So that is a two-dimensional array. So what I'm going to do is I'm just going to go ahead, type in my mat, and what that's going to equal to is an actual list here. So I'll go ahead and enter that. So what we're going to get after we go ahead and type that is we actually have a list that includes 3 separate lists. The first list has 1, 2, 3. Second has 4, 5, 6, and third has 7, 8, 9. So if we wanted to go ahead and create a matrix or a two-dimensional array, we would just hit mate and then NumPy, and then we will just go ahead and specify the array and what we're going to be passing in, a list of lists on my mat. So we'll just go ahead and hit enter, and then what you can now see is that it is actually a two-dimensional array. We have row 0, which includes 1, 2, and 3, row 1, which includes 4, 5, and 6, and row 2, which includes 7, 8, and 9. So the indexing for both rows and columns start at 0. We have column 0, which has 1, 4, 7, column 1, 2, 5, 8, and column 2, 3, 6, and 9. So NumPy has several built-in array methods that you can go ahead and either create a one-dimensional or two-dimensional array. So the first one we're going to look at is the arange. So it's very similar to the range function that's available in Python. What you can do is you can specify a start and a stop. So that's what I'm going to do this first time, a start and then a stop. And what that'll do is that'll create an array starting at 1 up through but not including 10. So we'll have the numbers 1 through 9 in the array. You can also include a step value. So if we want to go ahead and print out all the even numbers between 0 and 10, we can just specify the beginning, the ending plus 1, since the last number is where we stop, but it does not include that last number, and then our step, which will be 2. So if we go ahead and create that, we have the even numbers between 0 and 10. So the other thing with NumPy, say for instance, if you want to have an array that has all zeros, you can just call the zeros method, and then you pass in how many elements you want in that array. In this case, we're going to pass in 3. So what that will create is an array with 3 zeros. If you want ones, we can do the same thing, pass in 3. And let's pass in 5 this time, and what that creates is an array with 5 ones in it. The other thing you can do is you can create two-dimensional arrays with zeros or ones. So let me go ahead, type in np zeros, and then what I need to do is I need to specify a tuple, 2 column 3, so that should create a two-dimensional array with 2 rows and 3 columns, all with zeros. If we go ahead, that is what gets created. And we can do the same thing for our ones. So I want to go ahead and create a 3 by 4. So that should create 3 rows and 4 columns with all ones. Okay, so what we're going to look at next is we're going to look at linspace. So what linspace does is it returns evenly spaced numbers over a specified interval. So it is definitely different from a range, and a range will have a step value where linspace will have the number of points that you want evenly spaced within the start and the stop number. So let's go ahead and create an array. We'll call in linspace. Oh, let me see, make sure I spell that correctly. And what we're going to do is it's going to be between 0 and 5. And what we want is 10 evenly spaced points between 0 and 5. So if we hit enter, basically we start at 0, and then each one of the entries is evenly spaced between 0 and 5. So that's linspace. If we specified NP, we'll just show the difference between a range, and we wanted 0, 5. That'll be our step value, so that'll just show 0, 2, and 4, or the even numbers. You can use it, so if we want more numbers between 0 and 5, I could just go ahead and specify linspace again. We'll start at 0, end at 5, but we want 100 points, so if we go ahead and run that, there we have an array with 100 points that are evenly spaced between 0 and 5. The other thing that's really nice, especially for linear algebra, is basically what you can do is you can create a 2D square matrix where the number of rows equals the number of columns, and a diagonal of 1. There's a diagonal of 1 and everything else is 0. And that's called the identity matrix in linear algebra. So in order to create one, we'll just type in NP and then call our I function and specify the size of our square matrix. And what you see here is you have down the diagonal, you have 1s, and then everything else within the array is 0. So if you've worked with linear algebra, you would see the value of being able to create a square matrix. The next thing we're going to look at is that you can go ahead and create an arrays filled with random numbers. So the first thing we're going to look at is the rand function. So let me just type np rand and then rand. And then I'll specify a 5. So what this is going to do is it's going to create a one-dimensional array with 5 numbers of uniformly distributed random numbers between 0 and 1. So if we go ahead and run that, we can go ahead and see those random numbers. If you're going to be using the rand function quite a bit, you can go ahead and type the following, and you can shorten the actual command that you need to do to create those random arrays. So what we're doing is we're just importing rand from numpty.rand, and then if we want to go ahead and create a two-dimensional array with 5 rows and 5 columns of numbers between 0 and 1 that are uniformly distributed, all we have to do is type rand, and that'll go ahead and create that two-dimensional array or matrix for us. The other function that you can use quite a bit is the rand int, and basically what that does is it creates random integers based on a low value, which is inclusive, and a high value which is exclusive, and then you can also specify a size value which lets you know what the size of the array should be filled with random integer numbers. So what I'm going to do here is, if you want to go ahead and just create one random number and you want it in the range between 1 and 100, you would type 1 and 101. And then just hit enter, and that would go ahead and create a random number between 1 and 100. If you wanted to create 10 random numbers, the first thing you can do is you can do the trick from up above to shorten out the amount of typing. So we could just go ahead and import our rand int function. And then all I have to do is type in rand int. Excuse me, and we will go ahead and fill in an array with 10 random numbers between 1 and 100. And there we have our array. So what we're going to look at next are some array attributes and methods. So first I'm going to create 2 separate arrays. The first array will be the numbers between 0 and 24. And then what I'm going to do is I'm going to create a random array. I can just specify rand int since I did the import up above. And it'll be random numbers between 1 and 50, and we'll create 10 of those. And then we will go ahead and display that so we have our numbers. So first thing we're going to look at is the reshape method, and what that does is it returns the same array with a new shape. So basically, if we wanted to create our array that has 25 elements and basically create a two-dimensional array, out of that we could just go ahead and call the reshape method. and we can just specify the dimensions. So we want 5 rows and 5 columns. If we go ahead and hit enter, that has now reshaped that array with 5 rows and 5 columns. If you go ahead and specify, if we want to reshape that, but instead of specifying 5 rows and 5 columns, we specify 5 rows and 6 columns, it will return an error because the size of your array must fit precisely into the reshaped array. So if you have 25 elements in your array, you know you can go ahead and create a 5 by 5 two-dimensional array, but you cannot create a 5 by 6, which requires 30 elements. If we want to find the actual max of our random array, so we can just go ahead and call our max function on that, and what that will do is that'll return the maximum number. If we want the min, we could just call our min function. That'll return the min, which is 2. If we want to return the arg location of what argument the max and the min are, we can just call the argmax method. So it is 44, so 0, 1, 2, 3, 4, 5, it returns 5, and the other one we could do the same for our min, that should return 1, since it's found at position 1. And then the shape method returns the shape of the array, vector or two-dimensional array. So if I go ahead and run arr.shape, what that will return is what it's just specifying is that it's a vector or a one-dimensional array that includes 25 elements. If we go ahead and actually change the shape, change the shape and set that to our ARR variable, so I will just go ahead and reshape it now, but I want to save that reshape into our R variable. And I go ahead and display that. Now it's saved out there, and I run our shape on that. I need to spell that right. Shape, what it returns is that now it's a two-dimensional array. And the final thing that you can do is you can go ahead and get the data type of your array. So you just type in D type, and it'll go ahead and return what type of values are stored in your array. In our case, it's an int 32. So that's all I had for part 1 of this video. What we're going to be doing is we're going to be coming back to part 2, where we're going to look at indexing and selection and Numpy operations that you can perform on arrays. So we will talk to you later.